Hello dear students. So today we have to learn the second part of physical quantities and measurement. We have already started physical quantities and measurement. The first part, the introduction part, we have learned in the previous video. Today we'll learn the second part of physical quantities and measurement. Okay? So before starting the video, hope you all are well in your home. What we have learned, we have to recap a little bit that what we have learned in the previous video. In the previous video, we have learned that what is a physical quantity. So physical quantity, I have told anything that can be measured by some direct or indirect process, that is known as a physical quantity. Example, we have given length, mass, time, temperature, area, volume, whatever we can able to measure, that quantity is known as a physical quantity. And how we have to measure it, that we have also discussed in the previous video. So to measure, we need a unit. Okay, unit should be the standard value of same kind of physical quantity. Okay, and there also we have discussed, when we are talking about unit, generally there are three kinds of unit systems are used in whole world, that is CGS, SI, FPS, and latter the name has come SI, but before that it is MKS. Okay, so today we have to learn little bit of physical quantities. Okay, and how we can able to measure it. So first quantity what we have to start discuss about, that is length. Okay, we know we can measure length, but if anyone asks you what is length, okay, hope you all are having your copy and pen. So start writing the definition of length. So length is a distance between two fixed points. So what is length? Length is a distance between two fixed points. Okay, so this is known as length. Now the question has come that how can we able to measure the length? So for that we need a unit. So what is the unit of length? So in the previous video only we have discussed we can measure length by three different unit systems. So there are three different unit. Okay, so here for SI unit, which is previously MKS, now it is SI, that unit is meter. Okay, so it is abbreviated by a single term, that is small m. Next, if I am talking about the CGS unit, that is centimeter, and its abbreviation, that is cm. So you can write here, it is abbreviated. Okay, it is abbreviated by, for meter it is small m, and for centimeter it is cm. So I don't think it is new to you, it is very much common and you have learned it earlier also. And when we are talking about the FPS unit system, and that is feet, which is abbreviated by small f into t, small f into t. So these are the units of length. Now we have to find a little bit of relation between them. Okay, so here the main unit system generally we use, that is SI. Okay, so I have already told it is international system. Okay, system of international, or Basically it is a Latin term, I have told earlier, that is systemi internationally. So we have to follow the SI unit much rather than CGS and FPS unit. Now the question has come, how we can able to measure 1 meter? Means how much distance should be known as 1 meter. So our next target is to define 1 meter, that is definition of 1 meter. Okay, what is the standard definition of 1 meter? Let's see. It is told the path traveled by light in vacuum in 1 by, see the number, it's a very interesting number, 29 crores 97 lakh 92,458 of a second. What is it? It is told the path traveled by light in vacuum in this much of 1 second. Means 1 seconds, this much fraction, this much of 1 second, how much distance is traveled by light in vacuum, that is known as 1 meter. And now you may ask, sir, from where this thing is come? See, one very common thing I will make you understand. We all know, okay, in general knowledge or previously in class 5 science we have learned that the speed of light is the maximum. And do you know what is the speed of light? The speed of light in one speed of light is 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. Now you see this 3 into 10 to the power we have written, this is not an exact value. Okay, what is it? Basically the exact value is 29 crore 97 lakh 92,458 meter per second. That means in 1 second, understood? In 1 second light can travel this much of meter. So to remember this thing, it is little difficult. So that's why we make it easy, that is 3 into 10 to the power 8. Okay, so we are taking 3 into 10 to the power 8, but this one, the second one, is the accurate one. Okay, and now if it travels 1 second this much of meter, so to travel 1 meter, how much time it will be taken? That is 1 by this much of a second. That means the light traveled how much distance in this much, that is 1 by 29 crore 97 lakh 92,458 of 1 second. That much path length is known as 1 meter. Now you might be asking, sir, why you will take this much path length will be 1 meter? The reason is that we have taken earlier that speed of light is 3 into 10 to the power 8 meter per second, or 29 crore 97 lakh 92,458 meter per second. And that is not taken by me. It is not taken by me that it is the maximum speed of light. That is taken by scientist Einstein. Okay, and by that only we have defined 1 meter. What you have to do, you have to copy it and you have to remember it as a definition. Okay, so copy it first. If you have not copied it, so pause the video here, copy the whole things I have written here, and then come to the next part. So in next part we will discuss the conversions between different units. Okay, conversion of different unit system of length. Okay, how we can able to convert from one unit system to another unit system for the case of length, we all know that is 1 meter is equals to 100 centimeter, okay, as well as 1000 millimeter. In another word, 1 centimeter is equals to 0.01 meter. 1 millimeter is equals to 0.01 meter. Okay, 1 kilometer is equals to 1000 meter. So this is the metric systems we have already learned in class 6 or class 5, I'm sorry. But apart from this, we have to learn little bit of more thing, just like 12-inch is equals to 1 feet. So feet we have already learned that it is a unit of length in FPS system. So 1 feet equals to 12 inch. So 12 inch also 1 unit of length, but it is not coming in any system like CGS, FPS and MKS or SI. Now you might be asking, sir, then why we have to learn this? What is the reason for us that we have to learn this unit system inch? See, apart from this 3 unit systems also, many unit system or many units are there for different physical quantity we generally use, and it is used for a long time. Okay, for different purpose, this unit is taken as a standard one. Okay, maybe they are not a part of any unit system, but we have used it. See, nowadays also when we measuring our height, we will measure feet and inch. Okay, so otherwise generally we have to use meter, centimeter, but to measuring height, we are using this system. Not only that, 1 feet is equals to 30.48 centimeter. So that is a relation between feet and centimeter. 1 feet equals to 30.48 centimeter. And from here we can write that is 0.3048 meter. If I want to convert it in meter, so it is 0.3048 meter. Okay, not only that, apart from feet also, one very common unit system is yard. Okay, so till now also when we measure any length in cricket, we have to measure in form of yard. Okay, you have to remember 22 yards of pitch for playing cricket. Okay, so it is also a unit. It is equals to 0.91 meter. Okay, so it is 0.91 meter. So these are the basic units generally we have used. Now if it is told you then 20 centimeter equals to how much meter, so it is very easy, 0.02 meter. You can easily find out. 3 millimeter is equals to how much kilometer if it is asked. So we know 3 millimeter equals to 3 into 10 to the power minus 3 meter, and 3 into 10 to the power minus 6 kilometer. Okay, because 1 kilometer equals to 1000 meter and 1 kilometer equals to 10 to the power 6 millimeter. So these are the basic unit system, and I'm telling you from here much more conversions will come. If it is come 1 yard equals to 0.91, what will be 4 yard equals to how much meter? So you have to multiply 4 and 9 4 is 36, so 3.64 meter. So this type of conversions may come in exam as well as in our general daily lives also. We have to remember this thing. Okay, these are very common things and we have to remember. So the conversion parts of unit, it is over for the case of length. Okay, now we'll go for another thing. Next, To measure the length, we need a unit. But which instrument we have to use to measure it? Okay, that is a big question. That which instrument we have to use to measure length. Now you might be thinking, sir, is it a big question? We all know, we all measure, we measure it by scale. Okay, it is a simple thing. To measure a length, we use scale. And now, if it is told that I have given you one pencil, how you have to measure it. So for that, we need a scale. Let's see whether we are having or not. Okay, so assume this is our scale. So you might be thinking it's just simple wood, no marking, nothing is there. But we will use it. It is better. So we just try to draw our scale. Okay. So in generally, what scale we have seen, that is given for us for any geometrical measurement, that is 15 centimeter. So to draw a whole scale of 15 centimeter is little difficult for us. So let's see, this one, it is 0. So that is the measurement is done, that is division has done in the scale. Okay. Okay, so let's assume this is a scale. So if it is 0, this is 1, this is 2, this is 3, and assume it is 14, and here up to that it is 15. So we are having a scale of 15 centimeter. Okay, now I have to measure the length. So what things we have to measure here? Simple thing we are having with us. So you have to measure the length. So how we have to measure it? A very common thing for measuring, that one portion we have to keep it at the 0 point. Okay, and another portion up to how much it will reach, we have to take that value. Okay, so here we have to see that it is crossing 2, but it is not crossing the 2.1. So this is the length of the pen, or two colors the same. If you erase this thing, if you take another color, then I think it will be easier to understand. Okay, so I'm just trying to draw it. Might be it is not looking like a pen, it's looking like a stick. So don't be afraid, nobody will beat you now. So assume this is a pencil, and here we have seen it will reach up to this point. And if I have seen from here, see, if I look at this point from this place, so it seems to be like reaching in here. Okay, and if I want to see from here, so it is reaching here. And if I just want to see it perpendicularly, we have seen here. Now you might be thinking, what is the thing is doing here, sir is doing? Nothing. What I have done? I am just changing the position of my eyes and want to take the reading of the scale. First I have gone this portion, then I am coming to this portion, and then I just want to see it perpendicularly from here. Now you might be asking this, sir, we want to see the digit here. Whatever the direction may be, what is the problem? Yes, there is a problem. What is the problem? Let's see. If I have seen from extreme left, so we will see the exact value is here. Okay, that is in 2.2 from extreme left. If we have seen from extreme right, okay, whenever I have gone that side, If I have seen it from extreme right, the digit it is given, oh, let's say it is a centimeter scale, so it is 2.2 centimeter, that is the length of the pencil or pen. And whenever we have seen it from extreme right, it is coming 2.0 centimeter, that is extreme right. Now, if I have seen it straight line, that is vertically, okay, so that is coming 2.1, that is vertically straight. So, whenever we have seen the terminal value, the reading from different angle, we are going for different angle na? So when we have gone for different angle, different side, the value is coming different. Now the question has come, which one seems to be the correct digit or the correct reading? How do we understand? So for that case, we have to follow a rule. The rule is that, what is the rule? Rule is when the reading is shown, then, not shown, seen, then we have to see vertically. Okay, so we have to see vertically straight where the digit is coming, where the terminal point is coming. Okay, if we have seen from different angle, then whatever the values will come, that is wrong. Only this one is right. Okay, so that is a very common error we have done, that when we measure any length, we have seen the reading from any of the extreme point. If we see it by making an angle, then there will be a chance that our reading is wrong. So we have to see vertically straight. So if you see it vertically straight, then you will get the correct value. So this one is correct, rest of the things are wrong. Why this thing is happened? Now it is a question. Why this thing is happened? See, if I am talking about, if I am just giving a lens, a magnifying glass here, what is that? It is first division 2, then 2.1 and 2.2. Okay, so in between these three, we have told that 2.1, this is correct, because whenever we have to see it vertically, on that point we have seen this pen is exactly aligned with 2.1, not with 2.2 and 2. But whenever we have shifted our eyes in any of the side, then you see it is parallelly shifted. If it is 2.1, if I have seen from here, it is parallelly shifted to 2.2. If I have seen it from there, it is parallelly shifted to here at 2. So this parallelly shift is occurred if I have made some angle to see it. This error is known as parallax error or error of parallax. What is it? The simple thing. If we shifted our eyes at a certain angle to see the reading of a scale, then the exact value will be shifted parallelly, and that is known as parallax error. And for that, if you see it for different angle, we cannot able to see the exact value. That is error of parallax. But you might be thinking, sir, you have told, but we need such thing which can be written here. Yes, I will define the error of parallax. Let's see. So first I will erase it. If you want to draw, definitely you have to draw, and for that you have to pause the video here, draw it. Okay, and in the meantime I will write the definition of error of parallax. Okay, so I'm writing the definition. So okay, we have discussed about the error of parallax, and the definition I have written that a parallax error is the perceived shift in an object's position as it is viewed from different angles. The apparent position of the object is the parallel shift. Apparent position means where the object seems to be shifted. Okay, so if I keep the object here, if I have seen it from extreme left, this object seems to be shifted here, or if I have seen it from extreme left, it is seems to be shifted here, so forward or backward, but the exact position is here. Okay, that shift is known as error of parallax. So whenever we have to measure anything with the help of scale, then our eye should be vertically, okay, downward or vertically with the reading, so that our reading should be correct. So the question may be asked, what do you mean by error of parallax and how it can be solved? Okay, so what is error of parallax? It is written here, and it is solved that when we have to see the reading vertically, then the error of parallax is solved. Okay, so that is all about the measurement of length. Now we'll go for the another thing, that is the measurement of mass. Okay, that is measurement of mass. Maybe the discussion of error of parallax, it is little longer, but hope you all can able to understand. So another physical quantity is a very common physical quantity, that is mass. What is mass? I think it is known by everyone. So mass is the amount of substance in a body is known as mass. Amount of substance in a body is known as mass. Okay, and what should be its unit? So what will be the standard value by which we can able to measure it? So for SI, we know it is kilogram. Which is SI? I have told that is only the in case, and it is abbreviated by kg. The CGS value is gram. Okay, and it is abbreviated by small g, and FPS, that value is pound, and which is abbreviated by LB. Okay, so these are the general unit of mass. These are the general unit of mass. Hope you all know that. Now, as I have told earlier also, the SI unit is kilogram. So here we are more often get the value of mass by kilogram. Okay, so what is 1 kg? How it is defined? We have defined 1 meter, so now we have to define 1 kg. What is the definition of 1 kg? How much mass should be taken as 1 kg mass? So it is told that the mass of 1 liter of water at 4 degrees centigrade is taken as 1 kg mass. Okay, so what is written? That the mass of 1 liter of water at 4 degrees centigrade is taken as 1 kg of mass. Okay, so here also, as we have seen that there are SI unit, CGS unit and FPS unit, and apart from that also many units are there which we use in our general day-to-day life. So what will be the relation with that SI unit or the CGS unit or the FPS unit of mass, that we have to see. So next thing we have to see, that is conversions of the unit of mass, conversions of unit of mass. So if you have not written, so pause that video in the previous portion and see conversions of unit of mass. So it is very easy. 1 kg is equals to 1000 gram. Okay, 1 kg is equals to 1000 gram. So that is a very common relation and we have seen it very often. But apart from that, many more unit systems are there. Just like 1 quintal. So 1 quintal equals to 1000 kg. And if you convert it into gram, so it is 3 zeros are already there, 2 zeros are adding, so 10 to the power 5 gram. Okay, 1 metric ton. So 1 metric ton equals to 1000 kg, and that is 10 to the power 6 gram. So these are quintal, metric ton. These units are used to measure the large amount of mass. To measure the large amount of mass, these unit systems are used. Apart from that, 1 pound, that is LB. I have already told pound is abbreviated by LB. Okay, 1 pound equals to 453.59 gram. Okay, and from here we can write that is 0.45359 kg. Okay, so as we know the relation between kg and gram, so we can write it. Apart from this, the smaller units are already there, that is 1 milligram, that is 10 to the power minus 3 gram, and 10 to the power minus 6 kg. Okay, so these are the conversion of the units of mass. So if it is told, what do you mean by 1 kg equals to how much milligram? So it is very clear, 10 to the power 6 milligram. So if 1 milligram equals to 10 to the power minus 6 kg. So 1 kg equals to 10 to the power 6 milligram. Not only that, if it is told that 5.05 gram equals to how much kg? So it is 0.00505 kg. Okay, so we have to divide it by 1000. Okay, or apart from division, we can write it in another method also. That is 1 kg equals to 1000 gram. We can write here that is 1 gram equals to 10 to the power minus 3 kg. 1 by 1000, it can be written as 10 to the power minus 3. Okay, in a form of power. So here also 5.05 equals to 5.05 into 10 to the power minus 3 kg. Okay, so these systems also you have learned in class 5. I think you have remembered. Okay, whenever we have learned metric system, that time this conversions we have learned, and here these are the conversions of units of mass. Okay, so you have to remember this thing, because based on which many another conversions may come. Just like 1 pound equals to this we have learned. If it is told 10 pound equals to how much gram? So we have to multiply this with 10, that is 453.59 into 10, and here it is coming 4535.9 gram. Simple thing, this point will be shifted here, as 10 is here, so it will be shifted by 1. If it is 100, then it is shifted by 2. So simple types of calculations are there, so you have to do it. I think you can able to do any sort of conversions for mass. Okay, now we will go for the instrument. The instrument is used to measure the mass of a body, and the things we have seen around ourselves to measure the mass. Number 1, that is beam balance. And apart from this, another thing nowadays, that is electric balance. But beam balance is a very old thing and very common nowadays also. Whenever we have gone to market, we have seen that this type of thing is fixed. Maybe the drawing is not so much interesting for you. Okay, I'm trying my level best to draw the thing, and now I know many of you have already started typing, sir, whether we have to draw it in our copy. Yes, you have to draw. Next question, is it come in our exam? No, it will definitely come. It will not come. Okay, but then why we are drawing? We have to draw it because we are free. We just want to understand. No, it's a matter of joke. But yes, as we are free now, what should I do? Draw it. Okay, then you might be understand also. So there are two pen are there. This is left and this is right pen. Okay, generally in left pen we have kept the object. Okay, assume the substance we have put here, and in right pen we have put some weights. Okay, so when it is equal, equal means this is a straight line I have drawn. This is an indicator. It is kept like this way. If you see a beam balance, this is called an indicator or a pointer. Okay, it is known as a pointer. So what is the utilization of it? Now when the weight is more here in left side, then it will be shifted in this direction. Okay, so you have to give some weight here, so then it will come straight. If you give much weight which is more than this, so it will be shifted here. That means where the weight will be more, where the mass will be more, it will be shifted in opposite side. And when it will be in a straight line, then we can say this much equal to this much of weight. Okay, weight I am using several times, but we are talking about mass specially. Okay, so by that we can able to measure the mass of the substance, and this is the beam, and that's why the name is beam balance. So by balancing it, we can able to measure the mass of the substance. Okay, so that is an instrument by which we can able to measure the mass. Okay,